exchange point where we are trying to keep local traffic local. And they use also initiative from mobile operator. But with all these initiatives, only 23 million has access to internet up to moment in Tanzania. So that means with the traditional approach, we might even take 50 more years to connect the remaining 27 population. That's why the University of Dodoma is doing a research on how we can leverage the use of TV white space. So what is TV white space? TV white space is licensed but unutilized television band. For example, in Tanzania, we are aware that after the migration from analog to digital, we are using 470 to 694 for the digital terrestrial television. So when I say the TV white space, we are using that band to deliver broadband communication, especially in rural Tanzania. So a definition from ITU is that a TV white space are an unused portion of the spectrum allocated for TV broadcasting in continuous or discontinuous manner or in a geographical setting, but that spectrum is not efficiently utilized. For example, you can see this is, we have a graph showing the spectrum utilization in Tanzania, in Dodoma. You can see in the range of 407 megahertz to 694 megahertz, which is located for the digital terrestrial television, about 4 to 5 channels are used. That means around 24 channels are not used. And with the current policies, no one is allowed to use this digital terrestrial television spectrum for other use. But we are trying to see on how we can contribute with this kind of research to address the issue of policies that are currently available. So what we have done, since 2017, we conducted spectrum measurements around Dodoma, where we started with few districts, Bahi, Chamwino, and Kondoa. And we also noted that Bahi and Chamwino, which are around 20 to 60 kilometers to Dodoma city, somehow many operators have presence. So the status of internet connectivity is somehow good compared to Kondoa, which is located about 140 kilometers. And just to remind you, in 2 years back, the road to access Kondoa was very difficult. And this is the same story in most of rural area in Africa. And that was one of the hindering factor for most of stakeholders to invest and to have access to stakeholders and customers in Kondoa. But working with this kind of white space technology, we were able to connect around the 4 schools in Kondoa using the TV white space. So in the measurement, we published the paper, which is currently available in Springer. You can access it with the title, Toward Affordable Broadband Communication, a Quantitative Assessment of TV White Space in Tanzania. So if you visit Springer, this is a book chapter. So we have a chapter in that book. We had a presentation in Ethiopia where which readers to participate in contributing to this book. So some of the few results and the major observation from the quantitative assessment. In that exercise or that paper, we had 2 approaches. One was the pollution protection viewpoints, and the second approach was the use of experimental spectrum measurement based on energy detection principle. And we found that when pollution protection viewpoints approach were used, more than 120 megahertz are available as white space and can be used for other uses than broadcasting. And when experimental spectrum measurements were used, we found that around 184 megahertz are available as white space in Dodoma urban, and almost 100% of the variable spectrum is not used in rural Dodoma. So this presents a best case to address connecting the unconnected challenge using the TV white space technology. So actually, how TV white space work, there are different approaches, but the first challenge that one needs to address before deploying the network is the issue of interference. If you go through the literature, you find there are two approaches that one may use to address the issue of interference between TV white space user and the digital terrestrial television. The one is sense-only approach, and the second one is the use of geolocation database. For the first approach, sensing-only approach, there is a challenge associated with the hidden node. But the use of geolocation database has been identified as the best approach to address the issue of interference. So the University of Dodoma, actually, this is part of my PhD research, we developed a geolocation database, which is currently hosted at the National Internet Data Center. And the database is the one responsible for distributing the channel to the white space device. In doing that, we were able to address the issue of interference between digital terrestrial television user and the white space devices, especially in the coexistence environment. So, as I have said, a geolocation database tracks the availability of spectrum and make this information available to the device. This approach shifts the complexity of spectrum policy confirmation out of the device into the database. And this approach also simplifies adoption of policy changes, limiting updates to a handful of databases rather than numerous devices. So, as I have said, the piloting the use of TVOS for community network, we had about 3 overarching objectives. One was to guide a range of stakeholders so as to increase the use of currently underutilized TV UHF spectrum band. So this stakeholder range from policymakers, telecom or mobile operators, end users, and other community networks within and beyond Tanzania. The second objective was to attract more research and development investments on both dynamic spectrum access using TV white space and community networks. So the dynamic spectrum access concept is very important, as most of us, we are aware of the coming 5G. So if we deploy or leverage on this approach, it can also help to address a number of issues associated with that. And the third objective is that this research was to necessitate the discussion to establish a sound technical and legal framework to embrace both dynamic spectrum access paradigm and community network toward affordable broadband communication. So just to mention within this room is that in Africa, only South Africa has passed a policy on TV white space. The rest of us, the rest of countries in Africa have not yet have an official framework or regulation on the use of TV white space. But few countries are also doing research and pilots and test bed For example, we have Malawi, Ghana, Botswana, Kenya. Those are some of the few countries who are also doing such kind of initiative. So University of Dodoma in Tanzania is also joining the team and in researching on seeing the best approach of leveraging the unused TV UHF to connect the unconnected. So what is community network? Community network is a bottom-up approach and a feasible alternative to connect the unconnected. As I have mentioned in my previous slide, if we leverage, if we rely on the traditional technologies using corporates, using mobile operator, it might take more years to connect the remaining 27 million. But if we leverage the use of bottom-up approach, where communities are empowered to address their own local challenges related to connectivity, then there is a chance of addressing the interconnectivity around Africa. So in most cases, commercial internet service providers and the mobile operators are reluctant to invest in rural area due to the fact that return on investment is not realized in short time of period in this area. We are aware that spectrum fees still very huge, and also infrastructure cost is very high, and that's some of the hindering factor that makes mobile operator and commercial internet service provider not to invest much in a rural area. Thanks to the Universal Communication Access Fund, it is also working with few operators to connect, to bring the infrastructure in remote and underserved area. But still, the community network approach would be also an alternative to address the issue of connecting the unconnected. So this is the network architecture. As you can see, we have 3 schools that has been connected. We are backhauling with the Harotel. As you can see, we are using the Carlson wireless radios for the TV space, and the database, which is hosted in the National Internet Data Center, allocate the channel to the base station, which is located in Kondoa. And we are also using sector antenna covering 120 degrees. That's why we have 3 sector antenna. And at the end, at the schools, we have the receiving antenna, which is the log periodic antenna with the CPE device, and that is connected to the access point, and the end user get access to the internet using that architecture. So this is the Carlson base station that we are using, and it's currently installed in Kondoa. This is the link planning, where Kondoa Girls is the longest link, which is having around 4.6 kilometers. And we also have Ura Secondary, which is also 3.6 kilometers. And we also have Bustan Teachers College, which is located 1.4 kilometers. But there is a stall at Bustan Teachers College, because between where we have installed the base station at Harotel Tower to Bustan Teachers College, it is about 1.4 kilometers. But it was not that much easier to establish the link because of a very big forest that is between Bustan and the base station. And that forest is the source of water in Kondoa. But finally, we increased the power, we increased the height of the transmitter, and we were able to get connection at Bustan Teachers College. So this, some of the link profile when we were doing link planning and the link budgeting. And this is the internet speed that were able to be achieved. And there are also a number of challenges that we faced. One is lack of affordable backhauling solution. It's still very expensive, especially in the rural area. So when you are paying for the mobile operator or commercial ISP, then broadband is still a challenge. We also noted that there are still very high co-location fee, because if you are co-locating your devices to the mobile operator tower, then you have to pay for the co-location fee, which is still very high. And as usual, rural Africa, the power is also a challenge. The level of illiterate, lack of local content is also a challenge that we have noted. Lack of policy favoring the use of TV workspace, especially for the rural broadband, and lack of policies favoring the community network for rural broadband. So all this, it is not one stakeholder who can address. That's why we are presenting this. If we can join hands together, then we are sure that the remaining unconnected can be brought to the internet. So some of the sustainability model that we are testing, we are engaging SME and business partner operating in Kondoa to pay for the connectivity. And also we are encouraging the host education institution to take forward the project. But we also had a discussion with CEO from the Universal Communication Service Access Fund, and there is a positive sign of taking forward the project, especially for 1 or 2 years for the proof of concept as we are working for the sustainability model. We are also encouraging more partners to join and supporting us so that we can connect the remaining unconnected. And as we are all aware, in Tanzania, we are also leveraging the Ujamaa concept, socialism, where a certain group or individual community members can pay for the service to benefit other community members who are not able to pay for the communication service. So this is some of the steering committee members. We had a steering committee member from Kondoa, and this is some of the students who are getting access at Kondoa Girls High School. This is a girls-only high school with around 800 students and more than 46 staff. And this is Bustan Teachers College. It is having around 500 plus students and more than 30 staff. And both, you can see some of the technical team installing the antenna. And the best thing of community network is that one may think that in a rural area, there are no people who are capable of doing this. If you go in a rural area, you find people who are doing installation for the DSTV, people who are maintaining TV and the radios. So the same guys can be equipped and do and take forward. So for the technical sustainability, we are empowering community members around that area to make sure they have capacity to take forward. This is quite different from the other approach. And you know, this is when I noted that all targeted schools were connected. So this was my last school to connect. You can see how I'm happy to see the last schools connected. So thank you. And this project is made possible through a donation from the Internet Society and the University of Dodoma. Asanteni sana.
Thank you very much, Shabera. Any questions? It's quite impressive to see how this community is really helping itself. And for me, that's quite impressive. Any questions? No? Okay then. Thank you very much. Okay then.